Okay, another important topic that we want to make sure that we cover today is x and y intercepts. So the point at which the line intersects the x-axis is called the x-intercept. It's where it crosses the x-axis. Where it crosses the y-axis, of course, is called the y-intercept. Remember, the x-intercepts also have a few other names. We call them roots, we call them solutions, and we also call them zeros. So if you ever see any of those other terms, they all are talking about an x-intercept, okay? So all of these things. So if we are asked to identify the x and the y-intercept of the graph shown to the right, we would look here, okay? And so our x-intercept is going to be this point right here. It's going to be 1, 2, 3, 4, 5, 6, 7, 8, 0. Okay, so my x-intercept is going to be 8, 0, versus my y-intercept, which is where it crosses the y-axis, which is at 1, 2, 3, 4, 5, 6, 7, 8. So 0, 8 this time. Okay, so keeping in mind, with my x-intercept, I have an x value, the y value is 0, y-intercept, the x value is 0, and then I have whatever that y value is where it crosses. So to find an x-intercept, remember we talked about x and y-intercepts are a lot easier to find when we use standard form of an equation rather than the slope-intercept, but you could use any form that your equation is in. If you want to find the x-intercept, you are going to set y equal to 0 and solve for x. So if you want to find a solution or a 0 or a root or an x-intercept, okay, whatever is being asked of you in the question, you are going to set y equal to 0 and solve for x. And that works for any type of equation. It doesn't even have to be a linear equation. You could work that out for a quadratic or exponential or anything. Now, to find the x-intercept of an equation, we are going to set x equal to 0 and solve for y. So the exact opposite of what you would do for an x-intercept. All right, so to find an example question, we're asked to find the x and y-intercept of the equation y equals 3x plus 6. So to find the x-intercept, okay, notice it's not in standard form, so we can still do this. It's not a big deal. We're going to replace the y with 0 and solve for x. So I'm going to subtract the 6. I get negative 6 is equal to 3x. I'm going to divide by 3, and I find that the x-intercept is negative 2. So it's at the point negative 2, 0. Okay, now for the y-intercept, okay, this time we're going to replace our x value with 0 and solve. So 3 times 0 is 0 plus 6, so y is equal to 6. That means that 0, 6 is our y-intercept for this equation. Okay, so algebraically it's really simple. We're just replacing the opposite variable with 0 and solving. Okay, now a couple more examples of that. I'm going to actually do number 1 here. So first off, to find the x-intercept, alright, I'm going to replace the y with 0. So I have 0 is equal to negative x plus 5. I'm going to subtract the 5. I get negative 5 is equal to negative x. Remember, I have to get rid of that negative in front of the x, so you could multiply by negative 1 or divide. I'm just going to divide by negative 1, and I get that x is equal to 5. So I have the x-intercept is at the point 5, 0. Now, y-intercept, we're going to do the same process, but we're going to flip it around, keep the y, and replace the x with 0. Notice I've used parentheses here when I plug it in. Negative or positive, it's still 0, so 0 plus 5 is 5. So I end up with the point 0, 5 for my y-intercept on this one. Okay, now 3, same process. So this time I'm going to deal with a couple of fractions, but no big deal. We know what to do. We are going to replace the y with 0 is equal to negative 4/3 x plus 2. I'm going to subtract the 2. I end up with negative 2 is equal to negative 4/3 x. When I have a fraction as a coefficient, remember I flip it and multiply. So I have negative 3 over 4 instead of 4 over 3. So I multiply this side by negative 3 over 4. So I end up with x on the right, and then over here I will end up with a positive 3 halves. So I end up with an x-intercept of 3 halves, comma, 0. Now my y-intercept, remember that I'm going to keep the y and replace the x this time with 0, which is nice because when I multiply that fraction by 0, I just get 0. So y is equal to 2. And so 0, comma 2 becomes my y-intercept. And so that's going to be the algebraic way of finding these intercepts. So let's give number 5 one more look. These are in standard form. So remember, standard form is nice and simple because we're going to have very easy calculations to do. So first off, to find the x-intercept, I'm going to replace the y with 0. So what happens here is this negative 2 times 0 becomes 0, and we just have 3x is equal to 12. We divide by 3, and x is equal to 4. So 4, comma 0 becomes my x-intercept. With the y-intercept, same process. This time we're going to replace the x with 0. 3 times 0 becomes 0, and so all I have is a negative 2y equals 12. I'm going to divide by the negative 2, and y equals negative 6. So we become 0, negative 6 for the y-intercept. Okay, so algebraically, not too bad. Now, graphing to find the intercepts, we want to find the x and y intercepts and then graph the equation using its intercepts. So that's kind of a little bit different than what we may have done before. So let's find our x and y intercepts first. So x-intercept, remember we are going to replace the y with 0, so x plus 0 equals 3, so x is equal to 3. So I'm going to put a point at 3, comma 0. And then y-intercept, we have x is 0 plus y is equal to 3. And so we end up with y is equal to 3 on this one as well. So we have a y-intercept here of 0, comma 3. And so here I have 2 points, and I can line those 2 points up and make that a continuous graph. Now, I can also graph something a little bit more complex here in standard form with my x and y intercepts as well. So in the first one, to find that x-intercept, remember I'm going to replace the y with 0, so 9x minus 15 times 0 is equal to 45. That 15 times 0 becomes 0, so I have 9x is equal to 45, divide by 9, so x is equal to 5. So my first point is going to be 5, comma 0. That's my x-intercept. And then the y-intercept is going to be the opposite of that. So we're going to have 9 times 0 minus 15 y is equal to 45. So that becomes negative 15y equals 45. We're going to divide by negative 15. And so y becomes negative 3. And so that's going to be the point 0, comma negative 3. That's going to be my y-intercept. I'm going to put my point there, and then I can connect my points to make my line. Okay, so lots of practice problems here that you can do. You can do the algebraic. There are 3 additional practice problems. Use the odds as a guide for you on the even questions. And then down here, same thing here, you have these odd questions to help you with these even ones doing the same process. So important to remember for intercepts is that the x-intercept, okay, is where it crosses the x-axis. Y-intercept is where it crosses the y-axis. If you have any questions, make sure you ask, and I'll be happy to help you.